Hunt or become the hunted. Rule or be replaced. Over 50 million years, an ancient group of creatures evolved, dominated, and was then wiped out by the greatest catastrophe in the history of life. But strangest of all, part of their legacy is still alive today. This is the Permian Period, the world of killers before the dinosaurs. The water near the swamp was almost perfectly still. A lone Scutosaurus lowered its head to drink, the bony armor along its back glinting in the dry, scorching sunlight. It was not easy prey. Its heavy body, knobby skull, and armor plating running along both flanks made it a living fortress of the late Permian. But at the edge of the reed bed, something was waiting. Not a roar, not a single wasted movement. Only the eyes of Inostrancevia locked onto the only weak point on its prey's body, the neck. The moment Scutosaurus lowered itself further to drink, the predator burst out. Scutosaurus immediately turned, lowered its head, and charged straight ahead. The first impact was powerful enough to knock Inostrancevia sideways. The armor had saved it. Inostrancevia did not try to bite through the hard, bony plates. It circled its prey, waiting for a better angle to strike. After several rounds of struggle, Scutosaurus began to slow. Its breathing grew heavy, and its turns could no longer keep pace with the predator. The struggle ended beside the murky watering hole. One predator, one prey animal. In the Permian world, this was not the exception, but the rule. But Inostrancevia was not the beginning of this story. And before we travel even further back in time, leave a comment and let me know, where are you watching this journey from? Around 299 million years ago, Earth was nothing like the world we know today. All the continents had merged into one colossal supercontinent, Pangaea. Deep inland, the ground cracked dry, the days burned with intense heat, and the nights turned brutally cold. But near rivers, floodplains, and coastlines, life still crowded together and thrived. It was in those fertile regions that predators and prey were drawn closer together than ever before. Back then, the land did not belong to dinosaurs. It belonged to the synapsids, an ancient branch of life that would eventually give rise to mammals. From those creatures, an ancient dynasty began to rise. And that story began at the dawn of the Permian Period. In the hot, humid swamps of the early Permian, the most dangerous creature was not always the largest. It was the one that could strike first, Dimetrodon. Though often mistaken for a dinosaur, Dimetrodon was actually far older than they were. It was a synapsid, a branch of life that would eventually lead to mammals, including us. The name Dimetrodon means 2 measures of teeth, referring to its differentiated teeth. Sharp teeth for slicing, and larger ones for pinning and tearing flesh. In nature, it was a terrifying innovation. About 3 to 4 meters long, low-bodied, powerfully built, and moving on all fours. Dimetrodon resembled a giant Komodo dragon prowling through a prehistoric swamp. But the feature that made it stand out most rose from its back, a massive sail supported by long bony spines running along its spine. That sail may have served as a natural thermoregulator. By turning its body toward the sun, Dimetrodon could absorb heat more quickly. And when it needed to cool down, that same sail may have helped release excess heat into the environment. On cold mornings, that advantage could make the difference between life and death. At the edge of the floodplain, a herd of Diadectes was slowly foraging. They were pioneering herbivores of the early Permian, reaching nearly 3 meters in length, with low, broad bodies and sturdy, blunt teeth for processing tough, fibrous vegetation. But that morning, the cold had not yet left their bodies. A smaller individual broke away from the herd, moving more slowly than the others. And Dimetrodon saw it. It did not need a long chase. With just one powerful lunge from behind, its jaws clamped tightly onto the prey's flank. The hunt ended before the herd of Diadectes even had time to realize what had just happened. However, not every killer of the early Permian needed a sail to stand out. Sphenacodon chose a quieter approach, but one that was still brutally effective. It was lower, leaner, and far less conspicuous than Dimetrodon. About 2 to 3 meters long, Sphenacodon had a large head, a short neck, and a powerful, compact body. Its 4 limbs were relatively short, keeping its body low to the ground, and the long tapering tail behind it made up nearly half its body length. While Dimetrodon was more common in the east, in places like Texas and Oklahoma, Sphenacodon is better known from the west, including New Mexico, Arizona, and Utah. These 2 predators may have dominated different regions of Pangaea. But Sphenacodon's reign ended earlier. It is believed to have disappeared about 10 million years before Dimetrodon. But the disappearance of Sphenacodon was not the end. It was only an early sign that the Permian world was always changing, and that no ruler could hold its place forever. Farther upstream, another creature also carried a sail on its back. Anteosaurus. It was also a synapsid, but not a killer like Dimetrodon. Its body was smaller and more slender, with teeth suited for processing plant matter. Its sail may have helped it absorb heat on cold mornings, but Anteosaurus did not have the speed, jaws, or predatory advantage of Dimetrodon. It showed that the early Permian was not just a world of fangs. It was also an age of evolutionary experiments. But then the climate changed. Forests shrank, dry lands expanded, and a new generation of creatures began to rise. By the middle of the Permian Period, the world had begun to dry out. Forests shrank, giving way to vast, cracked, and unforgiving landscapes. An environment that demanded endurance and optimized massive size over speed. The largest predator of this period was Anteosaurus. It looked like some mutant cross between a tiger and a hippopotamus. It grew to about 6 meters long, with an appetite to match. From the outside, Anteosaurus was once thought to be too bulky to hunt effectively. Some hypotheses even suggested it could only live near water, or relied on ambush attacks and scavenging. But its skull told a different story. When researchers reconstructed the skull of Anteosaurus using X-ray imaging and 3D modeling, they discovered that inside it was a sensory system optimized for hunting. The balance organ in its inner ear was highly developed. The part of the brain that coordinated movement between the eyes and head was also unusually large. That suggests Anteosaurus was not just a lumbering mass of flesh. It could track its prey, adjust the angle of attack, and lunge forward far faster than once believed. On the outside, it had a massive skull, raised bony bosses above the eyes, a long crest along the snout, and a pair of powerful fangs. On the inside, it was a refined, predatory machine. Anteosaurus was a sign that the evolutionary arms race had entered a new chapter. Predators were no longer just getting bigger. They were learning to use their senses, their weight, and their bite to control the entire hunt. Ahead of Anteosaurus stood a herd of Tapinocephalus, heavy-bodied herbivores with thick, dome-shaped skulls. When danger appeared, the herd immediately closed ranks, pushing the slower individuals toward the edge. For many predators, numbers were a shield, but for Anteosaurus, they were how prey revealed its target. It did not charge into the middle of the herd. It chose the Tapinocephalus on the outer edge. The prey lowered its hardened head in defense, but Anteosaurus did not aim for the skull. It aimed for the neck. One close-range rush. Its jaws clamped down right at the junction between head and body. The struggle lasted only a moment. From a safe distance, a Moschops watched in silence. It also belonged to the giant Dinocephalian group, living in South Africa during the Middle Permian, in the same world as creatures like Anteosaurus. But Moschops was not a predator. It was a heavy-bodied herbivore, low and powerfully built, capable of reaching at least around 400 kilograms in weight. Its most distinctive feature was its short, thick, and extremely sturdy skull. That skull may have been used in headbutting contests between members of its own species. Against smaller threats, Moschops' size alone was enough to intimidate. But against Anteosaurus, it still had to stay alert. Because in this world, being large did not always mean being safe. Prehistoric chose a different path. It was only about the size of a modern wolf, small when compared to Anteosaurus, but far more agile and lightly built. Its signature weapon was a long, narrow jaw. Inside were razor-sharp canine teeth. It functioned much like a cutting tool, a powerful slashing bite, driving deep into flesh and causing rapid blood loss. The jaw joint was also specially reinforced to withstand the immense torsional pressure when the prey struggled. Unlike the imposing Anteosaurus, Prehistoric was a solitary ambush predator. It used its slender body for sudden bursts of speed, targeting small to medium-sized therapsids, such as Dicynodon, as well as other contemporary reptiles. Inostrancevia, an omnivorous giant with a bizarre appearance. Large bony lumps protruded from both sides of its head, with a rugged bony horn right on its snout, looking as though evolution had decorated it with considerable enthusiasm. Equipped with a versatile set of teeth, it could process both plant material and small animals. Thanks to its massive body mass, it could also easily stay warm to survive the freezing northern winters. "260 million years ago, the Permian reached its greatest peak. Predators had become more sophisticated. Animal life was more diverse than at any point during the previous 50 million years. It was the age of the Gorgonopsians. After millions of years of refinement, this lineage, which had given rise to Lycanops in the Middle Permian, diversified into dozens of species across the supercontinent of Pangaea, pushing the synapsid predatory blueprint further than ever before. The most powerful of them was Inostrancevia. With a body length of nearly 4 meters, it was an agile, active predator with a build reminiscent of a modern polar bear. Its skull was long and narrow. The jaw muscles were powerful, yet precisely arranged. Everything was optimized for the operation of its primary weapon, the canine teeth. Inostrancevia saber-like canines were not merely large. They were finely engineered, laterally compressed, curved, extending below the jawline even when the mouth was closed. A precise bite to the throat or the base of the skull That was all it needed to end a hunt. Many hypotheses suggest that it was an ambush predator. After a short chase, Inostrancevia would use its exceptionally powerful forelimbs to seize and pin its prey to the ground. The saber teeth would then drive deep into the victim, tearing into the abdomen in a brutal attempt to deliver the killing blow. As predation pressure from the Gorgonopsians continued to increase, herbivores were forced to change their defensive strategies. Scutosaurus was the late Permian's answer, a giant pariasaur with a massive body. It was entirely herbivorous. Its peg-like teeth were well suited for cropping the tough vegetation of the late Permian. But its most important adaptation was its armor. Bony plates embedded directly within the skin covered its back and flanks. They served two major functions: protecting the body and adding considerable weight to an animal that was already enormous. Staying out of sight of the hunters, a small group of Dicynodonts quietly moves through the scrubland. Belonging to the Inostrancevia branch of the Therapsid lineage, they were entirely separate from the dominant Gorgonopsian predators. With their low-slung, barrel-shaped bodies and distinctive tusks, they fed primarily on whatever vegetation the increasingly arid Karoo could provide. Their skeletal structure suggests that they were expert burrowers. These burrows helped them escape the extreme heat of the supercontinent Pangaea and provided safe shelter from the killing machines of the late Permian. Their small size offered another major advantage. A Dicynodont required only a fraction of the energy needed by an Inostrancevia. That meant when resources became scarce, the Dicynodonts could still survive. The giant Gorgonopsians could not. The abundance that had characterized the Middle Permian and early Late Permian was steadily disappearing. A harsher climate forced the vegetation to retreat. The hunts continued, but the line between being well-fed and starving was growing thinner. In that suffocating world, the species that required the fewest resources were quietly becoming the leading contenders in the struggle for survival. Something was wrong with this land, and Inostrancevia was the clearest sign of it. This herbivore, with its parrot-like beak and strange pair of tusks, was built to endure. It spent much of its time burrowing to escape the heat and feeding on dry roots and tough vegetation. Now, their groups are becoming larger than before, not because their population is exploding, but because individuals once spread across vast regions are being forced into the few places where life still persists. It is into this declining landscape that Inostrancevia moves south from the north. It has arrived in the southern Karoo, a troubling sign, because it would never abandon its own territory unless there was nothing left there to eat. Its saber teeth were still sharp. Its warm-blooded body still functioned efficiently, but this land was no longer generous. The herds of prey were smaller and more scattered. Hunts lasted longer, and every meal came at a greater cost. It brings down a Inostrancevia beside a shallow riverbed, but the meal is too small compared to the energy it has expended to obtain it. The land was quieter than it should have been at this time of year. Prey was becoming scarce, but that did not concern it. The only thing it felt was the hunger growing stronger with each passing day. The meal was over. Inostrancevia moved on once again, crossing a world that was dying. It did not know that. It simply followed its instincts to move, to hunt, and to survive. But before the Permian world collapsed, there had been an even older age, a humid world of endless coal forests, where giant insects ruled the air and crawled across the forest floor. This was the Carboniferous, the age of giant insects. Fossil evidence suggests it could grow to more than 2.5 meters in length, nearly half a meter wide, and weigh up to around 100 kilograms. This was Arthropleura, the largest arthropod ever known to have lived on Earth. For more than a century, this creature remained a mystery. Most fossils discovered were nothing more than scattered molted exoskeletons. No head, no identity. That changed when a discovery in France provided an answer. 2 juvenile specimens were preserved in exceptional condition, and for the first time, the head of Arthropleura was revealed. It was low and fairly rounded. 2 long antennae extended forward. Its eyes protruded from the sides of the head, much like those of modern crabs. Beneath them was a small but powerful set of jaws, creating a strange blend of a millipede and a centipede. But don't let this intimidating appearance fool you. Arthropleura was probably not a bloodthirsty predator. New studies suggest it most likely fed on decaying leaves, rotting wood, and dead plant matter accumulated on the forest floor. In other words, it was the cow of the ancient arthropod world. With such a massive body, it required an enormous amount of fuel every day, and nature provided exactly that. The Carboniferous world had very little competition. Vertebrates were only beginning to experiment with life on land. Many species still depended on water. True reptiles had not yet appeared. The Carboniferous period was the golden age of arthropods, and Arthropleura was one of its greatest beneficiaries. A giant but harmless Arthropleura. That was one of the rare pieces of good fortune in the Carboniferous ecosystem. Because not every arthropod giant was so gentle. Hidden deep within the darkness of the swamp forests was Pulmonoscorpius, a true predator. It was not as massive as Arthropleura. Its body measured only about 70 centimeters in length. But for a scorpion, that was still an impressive size. Unlike the giant millipedes wandering in search of decaying vegetation, Pulmonoscorpius was most likely a master of ambush. Moving little, patient, and extremely dangerous at close range. It did not need perfect eyesight to locate its prey. Millions of sensory hairs on its legs turned it into a living seismic detector. Every tiny vibration in the ground was captured. It could be the signal of a meal, or a warning that danger was approaching. At the front of its body was a powerful pair of pincers used to seize and hold a target. At the rear was the characteristic curved tail carrying venom. With a single accurate strike, the hunt could be over almost instantly. Today, traces of this animal survive only in the ancient rock layers of Scotland. All of them point to one fact. Long before dinosaurs came to dominate the planet, Earth's first forests belonged to arthropod killers. We still have not reached the strangest peak of the ancient world, because nature's most bizarre experiments took place on the floor of the deep ocean, long before the Carboniferous period even began. Around 360 million years ago, the ancient seas were dominated by Dunkleosteus. The name sounds almost awkward, so much so that paleontologists often refer to it simply as the dunk. Don't let that fool you. This was not a cute creature. It was a true nightmare. For many decades, scientists knew Dunkleosteus only from its armored head, because most of its body was made of cartilage, much like modern sharks. That made it both famous and mysterious. Only recently have new studies begun to reveal more details. Nearly half of its skull was actually composed of cartilage. Its jaw muscle attachment system was far more complex than previously thought. And remarkably, it closely resembled modern sharks and rays. But what made Dunkleosteus legendary was its jaws. It belonged to the armored fish group known as Arthrodires, the so-called joint-necked fishes. Between the head and body was a unique, movable joint. This allowed it to tilt its head upward when opening its mouth, creating an enormous gape. Then came the downward snap. Everything was over. Dunkleosteus did not possess true teeth. Instead, it had razor-sharp, bony plates, which continually sharpened themselves after each bite. And that bite was extraordinarily powerful. It may have exceeded 7,000 newtons, stronger than the bite of a modern lion, black bear, or hyena. Anomalocaris, the super predator of the Cambrian seas. The most successful predator of this period was Anomalocaris. It is often called the killer shrimp, but that name is somewhat misleading. Anomalocaris was not a shrimp, nor was it closely related to any modern shrimp. Large individuals could reach lengths of about 1 meter. That may not sound particularly impressive today, but in the Cambrian oceans, it was a super predator. Along both sides of its body ran a series of soft swimming flaps. They undulated with each wave-like motion, propelling the animal through the water with remarkable stability and efficiency. At the front of the body, 2 long appendages armed with hooked spines moved constantly, ready to clamp down on prey. Its biological radar was even more terrifying. Each eye contained at least 16,000 individual lenses, several times more than the eyes of a modern fly, making it one of the most advanced visual systems of the Cambrian period. At the center of its head was an even stranger structure, a circular mouth known as a mouth cone. Its tooth-like plates were arranged in concentric rings, continuously closing whenever prey became trapped inside. For many years, scientists believed it was the armor-crushing machine of the Cambrian seas. But more recent studies have revealed a different story. The prey-catching spines show no signs of wear from repeated impacts with hard shells. This suggests that Anomalocaris fed primarily on soft-bodied animals. That does not make it any less dangerous. Once it captured its target, it would clamp onto the prey's head with its circular mouth. Then its two frontal appendages would work together to violently shake the victim with tremendous twisting force. The motion broke apart chitinous joints and tore open the protective outer covering, turning the soft tissues inside into a feast. Anomalocaris was more than just a predator. It was the symbol of a revolution unfolding beneath the sea. "252 million years ago, the Permian world stood at the edge of an abyss, beneath the surface of the continents, the same lands that had nurtured the greatest age of predators in Earth's history. A mechanism of destruction had been building for millions of years. Now, the trigger was finally pulled. The Siberian traps awoke. Massive eruptions continuously pumped vast amounts of CO2 into the atmosphere. Global temperatures surged. The balance that had endured for 50 million years was shattered. The oceans warmed and lost their oxygen, suffocating marine life. Food webs collapsed from the bottom up. A million years of cascading catastrophe overwhelmed the planet. 96% of marine species vanished. 70% of terrestrial vertebrates were wiped out, including the saber-toothed predators and the vast majority of synapsid lineages. The Permian Triassic mass extinction was the worst biological disaster in Earth's history, more devastating than the asteroid impact that later ended the age of the dinosaurs. The Permian came to an end. The Triassic began. And with it came the first footsteps of the dinosaurs. They were ready to inherit a new world that would soon become their own. That was not the end. A few smaller species managed to hold on. They hid and quietly survived the harsh early years of the Triassic. Today, the descendants of the synapsids still dominate the world. Those resilient survivors continued to evolve. They traded bare skin for fur, developed the ability to regulate their own body temperature, and learn to nourish their young with milk. In other words, the strange beasts of the Permian never truly disappeared. They became the direct ancestors of every mammal alive today, including us. For 50 million years, they were the dominant force on this planet. Older than the dinosaurs, stranger than almost anything that came after them, and in their own way, no less magnificent. The Permian was a complete world, complex, harsh, and extraordinary in its own right. Do you think the dinosaurs would ever have risen if the synapsid ancestors of mammals had not been devastated at the end of the Permian? Share your thoughts with us in the comments below.